We also look at geometric sequences in this class. Geometric sequences. And they are a list of numbers as well, but instead of having a common difference, they have a common ratio. Geometric sequences have a common ratio. And remember that ratios compare to things. So if I have 2 apples and Mr. Lopez has 10 apples, the ratio of Lopez's apples to my apples is 10 to 1. Or 10 to 2. I have 2 apples, so 10 to 2 or 5 over 1. So the ratio of Lopez's apples to my apples is 5 to 1. You could also do the ratio backwards and say the ratio of my apples to Lopez's is 2 to 10, is 2 over 10. But this is Lopez over me compared to my apples. Likewise, when we have a sequence, and let's have a sequence that goes 3, 15, 75, 1 second here. Want to make sure I get this right. 375, 1,875, ... What kind of sequence is this? Well, we're going to look at the ratios. We're going to look at consecutive terms. We're going to compare this term to the one before it. And I'm going to use a Archie thing, that's for division. 375 divided by 75 is, well, I punched it in my calculator, so you need a calculator to do these, that's 5. So the ratio of this term to that term is 5 to 1. Let's look at the ratio of 75 to 15, dividing here. 75 divided by 15 is also 5. Let's check this one. 15 divided by 3 is also 5. And so we know, and we could confirm it over here as well, but we're beginning to suspect that the ratio, which we'll call R, the common ratio, is 5. We can now write a recursive function for this sequence because we know what the thing you do over and over is. You multiply by 5. So if when you divided we found it was 5, that means we're going to be multiplying by 5 to get from here to there. If we're going forwards, times 5 times 5 times 5 times 5. So f of n, here's the function down here. F of n equals the function value one step earlier, written like that, times 5. And for recursives, you always need a starting place, so I'll write and f of 1 equals what? This means that the value of the first term is something. Let's go find it. Well, here's the first term. Term number 1, term number 2, term number 3, term number 4. So the value of the first term is 3. So now you know, start at 3, start multiplying by 5, that will generate the sequence. And I will add one more piece of information. This list and these term numbers map perfectly to tables that we look at. Fifth term. So now it's a table, and what goes in here? What describes this top row? This top row is the term numbers, or n. And they're the inputs. Put in 1, get out of 3. Put in a 2, get out of 15. So these are the function values, or the outputs, f of n. I could put any of these n's in to my recursive system. In fact, I will try to now generate the 6th term using my recursive function. So scrolling up, if I want to find this value of the 6th one, I need to know the value of the 6th minus 1 times 5. That means that f of 6 equals f of 5. Oh, f of 5, the value of the one right before it, times 5. Now to proceed, I need to know f of 5. And I can look it up here. There it is, 1,875. So f of 6 is equal to 1,875 times 5. $903,750. F of 6 equals 9,375. That is using the recursive function. Here's a critical step. You need to know what f of 5 is in order to proceed. Luckily from our table we did know what f of 5 is.